Hello everyone, welcome back to the Gate Engineering online learning classes. In this video of quick revision series, you will learn about the operational amplifier and in which we will talk about the inverting amplifier and non-inverting amplifier. So first of all, just I will quickly explain what is the operational amplifier. Operational amplifier is a device which is used to perform certain number of operations like addition, subtraction, differentiation, integration, exponential, logarithmic, and so on. And it is also called amplifier because it amplifies the input signal at the output side. So what is the meaning of amplifier or amplification? Amplification means increasing the strength of the input signal to the output side. So now we'll talk about the inverting amplifier. Inverting amplifier is the one type of the operational amplifier. So here this is the symbol of the operational amplifier and it consists of two input terminal. One is the negative, another one is positive and one is the output terminal. We have one input voltage supply. If this voltage is connected to the negative terminal, this circuit is called inverting amplifier. If this voltage will connect to the positive terminal, it will be called as non-inverting amplifier. Because negative terminal is nothing but the inverting input terminal, positive is the non-inverting input terminal. It means if input voltage is connected to the inverting terminal, this circuit will be inverting amplifier. If input voltage will connect to the positive terminal, it will become non-inverting amplifier. So here these two resistors are connected. One is the input resistor, another one is the feedback resistor. So here we will see the two concept of this operational amplifier. One concept is regarding the virtual ground. What is the meaning of virtual ground? Let's consider potential at this node is VA. So this is I consider this is node A and this node is called B. And I assume potential at node A is the VA and potential at node B is the VB. So concept of the virtual ground is that voltage at inverting terminal is equal to the voltage at non-inverting terminal. So we can easily observe the voltage at non-inverting terminal, that is the VB, which is grounded. Therefore, voltage VB is equal to 0 volt and it can be clearly state that VA is also equal to 0 volt. This is the one concept. Another concept is current in the operational amplifier is always 0 ampere because of very high input impedance in the ideal operational amplifier. So current inside the op amp is always 0. So these two concepts are very important to simplify the any operational amplifier circuit. So now what I will consider, current in the input resistor is I1 and current in the feedback resistor is IF. So if we apply the nodal at the node A, we will get the current equation, that is I1 plus I1 is equal to IF. If I apply the nodal at this point, we will get I1 is equal to IF. So this is the nodal equation from node A. I1 is inserting to the node, IF is leaving from the node and 0 ampere is also leaving. So only it can be clearly seen that I1 is equal to IF. So what is I1? We can write I1 is equal to nothing but the current across the resistor Rin, and it can be written as the voltage drop across the input resistor, that is the Vin minus 0 divided by Rin. So how can we write like this? Potential at one terminal is Vn, potential at another terminal is Va, that is 0 volt. So it will be Vn minus 0 divided by Rin. So I1 is Vn divided by R1 or Rin. Similarly, we will write IF, which is equal to 0 minus V out or VA minus V out divided by RF. So VA is 0, 0 minus V out divided by RF. So IF is equal to minus V naught divided by RF. And here we will see current I1 is equal to IF. It means we can write VA divided by R1, which is equal to minus V naught divided by RF. If we simplify it to find out the output voltage will be minus RF divided by R1 into Vin. This is the output voltage of inverting amplifier when input voltage is connected to the negative terminal and positive terminal is directly connected to the ground. And if we talk about the voltage gain is nothing but the ratio of the output voltage to the input voltage. So V0 divided by Vi is the voltage gain, which is equal to minus Rf divided by Rin. So always you need to remember, if any question will come on the inverting amplifier, you can directly use this formula. to save your time in the GATE exam or any competitive exam. And if you are getting this question in your university exam, go through proper procedure like consider the potential at node A, that is the VA, consider the potential at node B, that is VB. Based on the virtual ground, both are equal and it is 0. So current I1 is equal to IF, and I1 can be written as Vn minus 0 divided by Rn, which is equal to 0 minus V0 divided by Rf, and therefore output voltage is minus Rf divided by R1 into Vn, and voltage gain is minus Rf divided by Rn. Now we'll see the non-inverting amplifier. As I already stated that if input voltage is connected to the positive terminal, it will become non-inverting amplifier, and this terminal is connected as a ground. Non-inverting terminal is connected to the Vn, and inverting terminal, that is the minus 1, is connected to the ground. Now here we know the potential at this node is 0 volt. Potential at this node is, I already stated that VA is equal to VB. It means potential at node A is equal to the potential at node B, which is equal to Vn at this point. So this is the Vn. I assume current in the R1 is I1, current in the RF is IF. So if you apply the nodal at node A, we will get the equation I1 is equal to IF, and I1 will be the potential difference across the resistor R1 divided by R1. So it will be 0 minus Vn divided by R1. And IF is nothing but the potential difference across the RF divided by resistor RF. So Vn minus V out divided by R. If we simplify it and we will solve it, we will get V0 is equal to 1 plus Rf divided by R1 into Vn. This is the output voltage, which is the function of the input voltage and the resistor given in the circuit. So output voltage is the 1 plus Rf divided by R1 into Vn, and voltage gain is nothing but V0 divided by Vn, that is the output voltage divided by input voltage, is equal to 1 plus Rf divided by R1. So now we'll see the difference between the output in the inverting amplifier and non-inverting amplifier. So here, if you see the difference in the inverting amplifier, if you see the output voltage of the inverting amplifier, this output is negative. Output voltage is the negative in the inverting amplifier. It means if input voltage is positive, output will be negative. If input is negative, output is positive. That means waveform is inverted. That's why it is called inverting amplifier. And in the non-inverting amplifier, output voltage is in the same phase of the input voltage. It means when input is positive, output is also positive. When input is negative, output is also negative. That's why it is called non-inverting amplifier. Waveform is not inverting in the case of non-inverting amplifier, but waveform was inverting in the case of inverting amplifier. Let me see a few examples related to the inverting and non-inverting amplifier. So you can do the better practice for the your university exam as well as your competitive exam. So here we have given R1 is 1.2K. R1 is given, and in this question he is asking to find the value of the R2. We don't have given any value of Vi and V0, but it is provided that gain is minus 1.83. Gain is minus 1.83 means gain is negative, and here input voltage is connected to the inverting terminal. Therefore, this circuit is inverting amplifier because input voltage is connected to the negative terminal and gain is also negative. Because in inverting amplifier we have seen gain is nothing but V0 divided by Vin, which was is equal to minus Rf divided by R1. So gain is always negative in the inverting amplifier, gain is always positive in the non-inverting amplifier. You can also solve the same problem if circuit will not be given, because sufficient information is given in the question with the help of proper sign convention of the gain. If gain is negative, it is inverting, gain is positive, it is non-inverting. So gain is minus Rf divided by R1. We can use this formula to find out the R2 value. So R2 is nothing but Rf, feedback resistor. So gain is minus 1.83. We can write minus 1.83, which is equal to minus R2 divided by R1, which is 1.2K. So if you solve it, R2 will be is equal to 1.2 into 1.83. So we will get some value of the R2, which will be in kilo ohm because R1 is in the kilo. So R2 will also be in the kilo. So this is the way by which we can solve the examples on the inverting amplifier. If any gain is given, some register value is asking in the question, we can easily solve. But first, we need to understand the whether gain is positive or negative. If gain is positive, we need to consider the formula of gain for non-inverting amplifier. If gain is negative, we need to consider the formula of non-inverting. We need to consider the formula of inverting amplifier. Let me see another example. In this example, design a circuit with one op-amp that provides a gain of 5.5. So here again, just you can see gain of 5.5 means positive gain. Positive gain. Circuit will be non-inverting. Circuit will be non-inverting. Assume you have a resistor Ri, that is the input resistor, 10 kilo ohm. What value would you choose for Rm? So first of all, we need to design a circuit. Question is given to design the circuit. It means we need to design an operational amplifier. So I will design an operational amplifier. We know this is the non-inverting amplifier. Minus plus is connected to the some input voltage Vin, and here we will be having input resistor along with a feedback resistor which will directly connect to the output voltage V. Ri is 10k ohm and this terminal is grounded. Rf is, we need to calculate the feedback resistor value, and gain is given. So gain is given, we know this is a non-inverting amplifier and we have already derived the expression for non-inverting amplifier. That was A, which is equal to V naught divided by V in, is equal to 1 plus Rf divided by R1. This is the gain formula for non-inverting amplifier, and gain is 5.5, which is equal to 1 plus Rf. R1 is 10 kilo ohm. We need to calculate the value of Rf, that will be 4.5 into 10k, and it will be 45 kilo ohm. So Rf is nothing but the 45 kilo.